And if we compare this, what we happen, the rainfall over the mountain area, we just concentrate on the mountain area. Here is the heaviest rainfall we have between August 8th and early August 9th. And this average rainfall in this mountain area exceeds 40 millimeters in this period of time. And I think this is the period that Xiaolinchun occurred the landslide. And for this large area, if we compare with what we have of the velocity we calculate, and what we have is this is a wind component. We have for the westerly component wind from the 0 to 3 kilometers. And here is the average rain rate I just showed you over the mountain. And we can plot this plot to show that for the highest rain rate we have, whenever we have a highest westerly wind component winds, we have a higher rain rate. And this correlation reached something like near close to 0.9. And in fact, this kind of relationship is not only occurred in this this case. I will show you the other case, like in the 3 years ago, for the Typhoon Morakot. Typhoon Morakot, you know, moving similar track. As you can see here, we have a similar rain band occurred over the southwest coast area. And here is the average rainfall over the same area. I just pinpoint that in the mountain top, mountain area. As you can see here, in this 15 hours, the average rainfall is higher than 20 or 25 millimeter. Haitang, another case in year 2005, that this is a strong typhoon and moving in this direction and induce this kind of rain band situation. And this rain band has 2 periods of time. The first period is 15 hours, the second period is 7 hours, and all have rainfall, this rain cluster developed over the strait and propagate into eastward into the plain and the mountain area. Another one is Typhoon. That's also in 2005. So from these cases, as I just showed you, that in fact Typhoon Morakot, the heavy rain occurred over August 8th. It's not a rare case. It's kind of occurred, you know, in the past. Okay, yeah. I would like to show you the kinematic structure of the storm. Since we have a double radar around the island, currently we not only have 4, one in here, Hualien and Qigu and Kenting. This belong to the Central Weather Bureau. Now we have a polarimetric radar, C-band, one in the Magong and the other in the Taichung area. So my colleague in Central Weather Bureau, they have conducted this dual Doppler analysis, okay, that's using this operational radar system. So here we show 2 kilometer, 3 kilometer, 4 kilometer winds. So that's, as you can see here, that for 2 kilometers it's more on the west coast, and for 3 and 4 kilometers it can show, you know, the structure of the typhoon very well. As you can see here, from 4 kilometers, the center of the typhoon from the circulation point of view is on the central of Taiwan, and the winds has the circulation, you know, has associated with typhoon can reach a certain part of Taiwan. So here, if we define this the wind from the westerly as a part of typhoon, it's okay, you know, but over here we do have a southwesterly wind occurred, and calculate the convergence here. We have large convergence, you know, associated with northwesterly wind and associated with these westerly winds. So to the point I just mentioned at the beginning of the presentation that to produce this plain area heavy rain, I think part of this convergence from the westerly wind and the northwesterly wind is one of the components of it. And this diagram shows the surface wind. We analyzed from the surface wind. Okay, here is the wind speed, the isogram. As here we have 40 knots, and the typhoon center is located over here. And if we examine the wind over the land, you can see the wind decrease dramatically. So in fact, near the surface, we have this kind of speed convergence due to the differential friction of the ocean and the land. Okay, I think that this also contribute another force in, for the convection to development. So we compare what we have in the model around that along the mountain, there's a flow uplifted by the mountain. So there's a high convergence zone over here. And over the coastal area, that's have air conference between the typhoon and maybe from southwesterly and 5 minutes. I will finish that. And we have speed convergence over there. So when the situation is favorable for this flow convergence and also the speed convergence, we expect they will have higher precipitation or rain rate occurred over the plain area. If this doesn't happen, then some typhoon passing by, we will have the highest rain rate over the mountain area. I think that's the reason the typhoon Herb has the highest rainfall over the mountain instead of over the plain area. Another evidence I would like to show you is the case we have studied in pure southwesterly monsoon situation. That in 2008, June 5th, there's a meso-convective vortex occurred over the southern part of Taiwan and bring the heavy rain to the southern part of Taiwan. As you can see, here's the westerly wind component we have. That's the jet structure we have, and